Hi everyone, just introducing here what is my favourite roofing square. It's called the Gibson 390B roofing square. Prior to this it was known as the Smallwoods 390B. Before using this Gibson 390B, just making the point here that you need to have some basic roof geometry knowledge and terminology. So moving on. This animated lesson will focus on how to use roof and square to mark the common and hip rafters. It can also calculate other components of a roof, such as the jacks, the purlins, and the lay boards. Just zooming in here just to focus on alignment points on the tongue. Here you'll see in red points that you will align on the edge of a rafter or on the edge of a board if you're marking any angle. So here you have the alignment points for the hip and common rafter from 66 degrees upwards. If the roof is 60 degrees upwards, this is where you'll align it with. So now we're going to slide on up here further along the tongue, which is a narrower blade on the square. And here are the alignment points from 0 to 66 degrees roof pitch for the hip and common. And just highlighted in pink here, just showing you the what's printed on the square itself, that which relates to the common rafter length per meter of run, and how you can use these factors, as I could call them here, depending on what pitch the roof is. You can see there, in this case we're using 10 degree pitch as an example, how you can calculate the length of your rafter line. And here's just a little animation showing you how it's all relates. Here you can see for every 1 meter of run, if it's a 10 degree roof, then the rafter line or the hypotenuse of that right angle triangle will be 1.0154 meters. So next we're going to just go through how the length of the hip rafter is determined. And again, you can see they're highlighted in pink. Again, we're just using a 10 degree pitch, roof pitch as an example. And you can see that that factor there, that 1.4252, is multiplied by the common rafter run. Now I know we're dealing with the hip rafter, but it's based on the common rafter run if you look carefully there. So I suppose the good thing is you don't have to work out the hip run. So here next we're going to focus on aligning to the pitch that's on the blade. As stated earlier, we're currently looking at the tongue, which is the narrower blade, as it were. So the wider one is known just as the blade. So here's your common rafter run alignment point lined up with the red line, and the other end of that line then is lining up with the pitch point on the blade. And you can see there we're lined up with a 30 degree for a 30 degree pitch of roof. So just want to help you visualize how this relates to the right angle triangle of that forms your typical roof. So here is your right angle triangle in red, and so it's a scaled down version of your roof, really, is what the square is based on. So here you'll see there's the common rafter run point there. So from here to here the run, and from here to here would represent the rise, and then of course from here to here is the rafter line length, all scaled down of course. But of course, for the purpose of just getting angles, whether you scale an angle up or scale an angle down, the angle doesn't change. So often when you're just figuring out angles, you can scale everything down anyway. So just going through the animation here just to nail the point home, as it were, that I've just made there verbally. There's a visual on it. So as stated here, yeah, on the wide blade we have the plumb cut there now, and on the narrower blade we have what's termed the seat cut. Yeah. the pitch of the roof is shown in blue. So typically I tell apprentices to get a sheet of plywood, maybe a sheet of melamine preferably, because you can see the pencil lines easier on it, and typical, same as a drawing board, shall we say, same size, and mark all your angles on that. So here we have our drawing board, as it were, and we've now pivoted the square in line with the edge, and using the common rafter run point there circled in red, and now we've drawn our plumb line and for a 30-degree roof, and now we're drawing the C-cut line for that 30-degree common rafter. Yeah, just shading in there in yellow, the common rafter plumb cut, and later on you'll be setting your bevels to these angles when you're marking the actual rafter. So there are 2 bevels already now for you to set to: common rafter plumb and common seat. And also making the point here that if it's just an angle you want, well, that is a 30-degree angle there if it's something other than a roof. To get the alignment for the common rafter, multiply the half span of your roof by the common rafter factor for your roof pitch. And I've just animated that in here just to focus in on your roof and square where you'll see those figures. And here I'm using an example for a 30-degree roof. The top factor there relates to the common rafter, and the lower factor relates to the hip rafter, by the way. So I just did another animation here just so as you can visualize how the roof and square itself interacts with the actual rafter. So and how the cuts compare. Next we shall get the plumb and C-cut for the hip rafter by rotating on this point here. So we're holding at the pitch of the roof here, and now we're rotating down to the H and V point over here. Now, of course, when you go from the H and V point, we're not drawing a 30-degree line here. It's only from the common rafter run that you get a 30-degree line. So here we are now drawing the plumb cut and C-cut for the hip rafter for a 30-degree roof. And obviously this pitch then is lower than 30 degrees because it's the pitch of the hip rafter. So here's your hip rafter plumb cut, and here animated now is your hip rafter C-cut. And again, you'll be setting your bevels to that later on when we're marking the rafters, when we're marking the hip rafter. So this is an example for a 30-degree roof, which will multiply the roof half span by the hip factor, which is 1.5275, to give us the rafter line distance that's shown right here. So now let's go through the process of marking the actual rafters themselves. I just did a quick animation here showing the rafter sliding across our screen. So we'll go through that here now. So first up will be the common rafter. So here coming into view now will be your common rafter in the distance, and we're going to zoom it up. And we'll zoom up here to the end on the right hand side there. And we will be hooking our tape after we draw the plumb cut. And that's the common rafter plumb cut now off our setting out board. After the necessary deductions, we'll first of all draw the first deduction, which is half the ridge board. Okay. So now we shall hook our tape and measure down the length of the rafter down to the heel line, which is at the back of the wall plate or back of the bird's mouth in line vertically. So here we are hooking our tape, and here we're arriving down to where we shall be marking the bird's mouth. So you continue on with your tape from the top corner. Appears here now. So the length we got from our calculations, I always mark the top edge of the rafter. That's where I work from. And I have my distance marked there now. So now I'm going to draw the same as the plumb cut on top is the same angle down here for the heel line. So basically, if we take the tail run, which is measured horizontally from the back of the bird's mouth out to the fascia, and multiply that by the common rafter factor, we will get the length of our tail, which is animated here now. So there's our fascia cut being marked. So now let's go through the process of marking those cuts and lengths marked onto the hip rafter. Very similar process, just there's a few more deductions, etc. we have to be aware of. So we'll delve into that here now. Coming into view, hip rafter, and again we're going to zoom it up, and first thing we'll do is we'll set our bevel to the angle that we marked earlier on our setting out board for the hip plumb cut. Mark it in line with the top corner, because therefore when I hook my tape there, then I know I'm measuring from the exact point, so I have somewhere to hook my tape to that I know lines up with the plumb line. And but before we do that, we're going to have to make some deductions to allow for the thickness of the members that interact up at this point in the roof. So we have to take out, the first deduction has to be half the diagonal thickness of the common rafter, which is basically draw a 45-degree line on the top edge of your common and take half of that, and that gets you to that yellow line there. And then you're now on the point of the hip rafter, and then to get the shoulder to form that point, just come back half the thickness of the hip itself. And of course they're all measured square off the plumb line, as you notice there with my tape just before this here now. So now we're going to hook our tape on now that we've multiplied the hip factor by the common rafter run, and we will arrive down here to where we shall be marking the bird's mouth for the hip rafter. And so again, it's the same angle that we set our bevel to on top, so it's still the same as the plumb cut down here. So our heel line and the plumb line are the same angle, so we don't have to change the bevel or anything like that. So mark your heel line, which is now in line with the corner of the wall plate, but usually we cut a little bit off the corner of the wall plate so it sits in neat. So, and usually we bring that in by half the thickness of the hip itself, so that gets you into that yellow line there. So that's where we'll also then put our upstand, which is the vertical distance down from the back of the common rafter to its bird's mouth, and we keep that same distance here, so the back surface of the both rafters are on the same inclined plane. So again, with the tail here, we shall be taking the common rafter tail run and multiplying that by the hip factor to get the length of our hip tail. And again, that brings us down to the point at the fascia, but to form that point then we need a shoulder line. So again, you're measuring half the thickness of the hip itself to get to that point. So hopefully you can now mark the plumb and C cuts for the hip and common rafters, as well as their lengths, including required deductions. Remember, multiplying the common factor by the common tail run will give you the common tail length, and multiplying the hip factor by the common tail run will give you the hip tail length. So hopefully that was of use. All the best.